Hello, we are Team 54 and we'll be talking upon Walkerton water crisis. I'm Ashwini Nair. I'm in my second year of Masters in Civil Engineering. I would like my fellow teammates to introduce themselves.
Hello everyone, myself Rishisha. I'm currently pursuing my master's in civil engineering with specialization in project management, and I'm a first year student.
Hello everyone, my name is Thoy and I am a second year master student in chemical engineering and the last person is next.
Hello everyone, my name is Gulam Rabbani. I am a master's student in mechanical and manufacturing engineering. I am on my first year.
So, moving forward with our presentation, um, in May 2000, Walkerton's drinking water became contaminated with E. coli and Campylobacter. Within days, residents fell violently ill. Seven people died, and more than 2,300 people got sick. The worst public health water disaster in Canadian history. This wasn't a mere accident. It was the result of preventable failures in protection, treatment, monitoring, and disclosure. The crisis showed that ethical negligence can be just as deadly as technical mistakes. Moving forward with the background of the tragedy, Walkerton relied on shallow groundwater wells that were vulnerable to surface runoff. After heavy spring rains, manure washed into well number 5. Chlorination and routine monitoring were inadequate, and low chlorine residuals weren't properly addressed. Early complaints and lab results didn't trigger swift escalation in this case. Those gaps, like source protection, treatment, and communication, lined up to let pathogens reach people's stats. So this is the arc of the event. In May 2000, heavy rainfall contaminates well 5. Residents soon fell ill in that year. On May 21, a boil water advisory is issued. The province and public health units launch an emergency response and investigation. Town water staff are suspended and the O'Connor Walkerton inquiry begins. By 2002 to 2004, the inquiry details system failures and negligence. The Coble brothers are convicted for falsifying these records. In 2006, Ontario passes the Clean Water Act, extending protections to water sources province wide.
As already discussed, in May 2000, in the small town of Walkerton, Ontario, 7 people died and over 2,300 others became seriously ill. This was not a natural disaster. It was a failure of the system, failure of a law, and critically catastrophic failure of engineering ethics. Focusing on its ethical side of this case, the central ethical dilemma in Walkerton was the conflict between economic efficiency and public safety. Decisions at every level reflected a dangerous prioritization of cost cutting over protecting human life. The result was a system where safety was treated as optional instead of essential. To provide a detailed discussion, I have separated the causes of ethical failures into two primary parts, focusing on first part, the operators. The water utility was managed by unqualified and inadequately trained operators, Stan and Frank Cobell. They failed to maintain a proper chlorine levels and submitted falsified record to conceal their mistakes. Ignoring repeated contamination warnings, they violated the fundamental ethical principle of honesty, competence, and public protection. Moving forward to second part, the system. The responsibility also lies at systematic level. The Ontario government's budget cuts to the Ministry of Environment reduced inspection and shifted from mandatory regulation to voluntary conformance. This policy choice placed financial savings above human welfare, dismantling the very safeguard meant to prevent such disaster. To sum up my part with ethical lessons and outcome, the Walkerton water crisis violated the most fundamental principle of engineering ethics, the duty to hold paramount the safety, health, and welfare of the public. The tragedy led to the Safe Drinking Water Act of 2002, which enforced strict regulation and accountability. From this, the lesson is pretty much clear. Law and safety is the floor, not the ceiling. Engineers must never let economic pressure compromise their moral duty because in our profession, negligence can cost human lives. It is ethical duty of every working profession and it cannot be avoided.
In this part, I am going to use Apega's Code of Ethics to analyze the case. So, as you may know, in Canada today, engineers are guided by codes of ethics such as Apega's Code of Ethics. These rules provide a guideline for responsible practice. While the Walkerton cases happen in Ontario, we can try to use Apega's rules to highlight exactly what ethical duty we're missing. So the question here is which ethical principle were violated in this case by the operators? To answer that questions, the operators would have violated several key principles. First, number one, paramount safety. The operators failed to protect public health and they allowed contaminated water to enter the town's water supply, which directly endangered the community and led to serious illness and deaths. Next, rule number two, competence. They neglected proper water treatment standards and continued to operate beyond their level of training and ability. This shows a lack of professional judgment and accountability. Finally, rule number three, honesty and integrity. Instead of reporting accurate results, they falsify water quality records to hide the contaminations. So this is how we analyze the case using Apega's rules. The Walkerton case also reminds us that professional codes are only effective if they are actively followed. It is not enough to have rules written down. It must be applied in any situation to avoid cutting corners when facing pressure or just simply to get convenience.
The Walkerton water crisis stands one of the most tragic examples of engineering and ethical failure in Canada. Reminds us that ethical responsibility in engineering goes far beyond the technical works. It's about protecting lives through honesty, accountability, and communication. So, at what point should an engineer refuse to work or speak out when safety standards are being ignored? In my opinion, an engineer must act at the moment they recognize a threat to public safety. According to the APEGAS rule, our top priority is to protect the health and welfare of the public. Speaking up, even it's uncomfortable or against authority, it's a part of ethical leadership and professional integrity. So, what happens when engineers fails to communicate risk or ignore ethical responsibility? In that case, the results can be devastating. As seen in Walkerton, the operator's failure to report contamination in time that caused thousands of illness and losses of life. Beyond the tragedy, it broke public trust in engineering system and government. To conclude, Walkerton teaches that drinking water safety relies on multiple rigorous and maintained barriers, from source scrutiny to rapid disclosure. Its legacy brought stronger regulation and stricter accountability, reminding us that even small lapses in the ethical judgment can have catastrophic outcome. As an engineer, our duty is not only to build system but to protect people through integrity, vigilance, and the courage to do what's right. This is the end of our presentation. Thank you for unwavering attention, everyone.